Good morning, good afternoon, good evening, everyone. Thank you very much for joining this scheduled webinar on hands-on introduction to Fusion Metadata Registry. I hope everyone can hear me okay. If there's any problems with the audio, please can you put a message in the chat or get some thumbs up on a file. Perhaps we have doing one of the standard XML JSON formats that SDMX defines. Maybe we've got those from another source, then we can load them from file here, or in fact there's an option here to load directly from URL. And what that means is that if there is a someone provides a SDMX API structure service, then you can put the URL in there, and the Fusion Metadata Registry will import those structures directly from the URL. But importantly now, if we now go back to our structural metadata, and maybe we go to Codelists, now what we see is a little button up here with some little cogs on it. And this is to do with structural metadata maintenance. So clicking on that we see some options. We now see an option for creating code lists, editing code lists, deleting code lists, and this thing called managing annotations. So if we maybe wanted to maintain a code list, we can go in here, we can choose our code list, and we can go to our maintenance menu here, and we can choose to edit our code list from the maintenance menu. And that's the same for all of the structures here. So if I were to choose another structure, maybe data structure definitions, I can choose the DSD that I want to maybe alter. Choose the same option within the maintenance engineer, and we can see this option to create a new data structure definition or edit a data structure definition. And that's the same with every structure in Fusion Metadata Registry, no matter what it is, whether it's an organization scheme, whether it's a data structure definition, whether it's one of the item schemes like categories, concepts, code list. Every single one works in exactly the same fashion. So I'm going to leave the UI just for the minute, and maybe return back to the presentation if I can find that. Just recap what we're seeing. So this is what we're seeing in the user interface anatomy. So we can see down the menu items. We've got the section of structures for creating and maintaining structures. We've got our login and logout button, which is very useful. So if you're not just browsing the registry for content, if you do actually want to create and maintain structures, you do need to log in. So the login button up in the top right hand corner helps you to do that. We've got these individual items for organizations, for the data related structures, and also the item schemes concerning code lists and concepts and these other slightly more exotic things like value lists. We can use this load structures button to actually load structural metadata, or even actually referential metadata, but we can load that directly from a file or URL if we have that already. We've got a place to maintain our referential metadata. And some of the things we didn't look at, there's also an option to do some bulk functions. So we can bulk download. You can choose to download the entire structural metadata content of the registry into one file, if that's useful. If you want to move it perhaps between instances. And there's some other things like exploring the references between the various artifacts, which is very helpful if you've got a very complex data model. And various other things that we've already looked at. One of the other things that just wanted to highlight here is this language selector up in the toolbar, which you might have spotted. So SDMX is multilingual to the extent that the names and descriptions of the artifacts can be in different languages. So if you do have multilingual artifacts that you created or you imported into your registry, Then you can choose the display language you using the select selector at the top there. So it'll display in the selected language, or maybe in the default language if the artifact isn't in that particular language. And also, as well, in the middle, we have this option for textual search, where we can actually do a Google style search for artifacts. So you can put in any sort of search string into that, and that'll search the structural metadata and find structures that match that. So very briefly, let's just remind ourselves what FMR actually is. So we define it as this thing called a structural metadata registry to the SDMX specification. So if you go to Wikipedia, Wikipedia tells us that a metadata registry is a central location in an organization where metadata definitions are stored and maintained in the control method. Well, that is indeed the case. That is fundamentally what FMR is designed to be. It's designed to be a place for central storage of structural metadata. But as we'll see in a minute, it does have other use cases which are sort of particularly useful for maintaining and sort of modifying structural metadata. By structures, so as we've already seen in SDMX and in Fusion Metadata Registry, what we mean by structures are these structural metadata artifacts, so these code lists, the concepts, the data structure definitions, category schemes, all of the things that we've already seen. But in Fusion Metadata Registry 11 and in SDMX3, that also includes referential metadata reports as well. So if you have a use case for referential metadata, then the reports, the actual referential metadata, are treated in the same way as structures in SDMX3 can actually be stored in Fusion Metadata Registry. And finally, this bit, what do we mean by the SDMX specification? Well, FMR 11 actually uses the SDMX3 meta model. So underlying FMR 11 is actually the SDMX3 structures. But that doesn't mean that you can't work with some of the earlier models like the SDMX2 2.1 model. And by and large, FMR 11 is backwardly compatible to SDMX2 2.1. So just a final note here, I use this term meta model. Well, SDMX often uses the term information model, but fundamentally the two terms are interchangeable. So just to remind ourselves of the SDMX3 information model, I've included here a sort of like a simplified sort of summary of all the artifacts within the SDMX3 information model, which may be useful as a reference. And these are grouped, I guess, into these sort of various functions of data modeling, referential metadata modeling, data discovery, and data transformation and validation. So this is sort of like all of the structures that FMR will handle. In fact, there are actually a few more than that, but these are the main ones. But what we can see in here is the ones we're generally interested in, certainly in terms of data modeling, defining our data sets, are these key ones: so the data structure definition, the data flow, and the concept and the code list. So all of the structures within SDMX3 by and large are supported by Fusion Metadata Registry 11, but the key ones are also highlighted here. And just to remind ourselves of the SDMX 2.1 information model. So this is a slightly different view actually of the 2.1 information model, where we have exactly the same structures. So fortunately, all of these are backwardly compatible in FMR 11. So if your use case is to work with 2.1, as of course many institutions still are, then all of these are still supported. So there's no need, there's no specific requirement to implement sort of specifically the SDMX3 structures. The existing structures here of the code list concepts, data structure definitions, and the agency schemes are all supported. Probably a couple of things to note in as we spotted earlier, the hierarchical code lists, as they were called in SDMX 2.1, are actually now modeled as SDMX3 hierarchies. So you'll see that name change. And also, if you use structure sets in SDMX 2.1 to do mapping, then structure sets in SDMX 3 have been remodeled, and they're actually called these things called structure maps. But if you do load SDMX 2.1 structure sets into FMR 11, they will be converted to this newer form of SDMX3 structure maps when they're loaded. So I think the takeaway here is that there is a good backward compatibility with an FMR 11 for the SDMX 2.1 information model and existing SDMX 2.1 structures. The thing to be aware here is in these isolated cases of these hierarchical code lists and these structure sets, there is a conversion that will happen if you do load the 2.1 structure into SDMX 3. You will see they're actually converted into these SDMX 3 these updated structures. So finally, before we just get on with a little bit more of the hands-on, just a very quick reminder of the key use cases. So we saw from the definition of FMR earlier that its sort of main function is as a centralized metadata repository. Well, that indeed is the case, and that may be considered its sort of main purpose, and that allows us to do some very useful things, particularly in institutional context, in terms of externally and centralizing our metadata, so getting metadata out of spreadsheets, out of individual silos, out of individual systems, and things, and putting in a centrally managed and governed repository, and that's very useful because it allows us to reuse metadata artifacts. So maybe code list concepts and data structure definitions defined and maintained in one data domain may be very useful in another data domain. So if you're in a centralized place, they can be used and shared, and we can also do useful things like harmonization of concepts as well, if everything's in one place. So centralization is a very key element of centralized storage of structural metadata. Is a very key element of a very key use case for FMR. But probably one of the other very useful things is using its web user interface, which we've already seen a little bit, and this a little bit later, is the ability to author and maintain SDMX structures. So as a data modeler, or as a statistician, or anyone who wants to sort of create and maintain, or even browse and work with SDMX structures such as the code lists and the DSDs, then FMR is a very useful tool for allowing you to do that using the web user interface. Data collection as well, so it does support a data collection use case for perhaps sharing of structural metadata with reporters. So if your use case is collecting data from reporting counterparts, then the reporters will need to know in what structure they need to submit their data. Well, putting that structure, or defining that structure in SDMX and sharing it in an FMR instance, or even just sharing the SDMX, that's very helpful because it provides reporters with a very clear definition of the structure of the data they're going to report. And from the point of view of collection, then as we mentioned earlier, then we can use this function called Excel data reporting forms, or data reporting templates, to provide reporters with a simple way of reporting their data via Excel, which we won't look at in any more detail. But equally important from the data collection point of view is when we receive data, then we can use FMR to actually validate the data that we have received using the structural metadata definition, and we'll see that in action a little bit later when we have a look at the data process. And finally, from the data reporting side as well as the data reporter, FMR 11 has some use cases, so validation of data prior to submission. So again, using the same validation functions as a data collector may use. Then the data reporter can very easily run an instance of copies of FMR, and provided they have a copy of the SDMX structures provided by the data collector, then it's very easy to validate the data via to submission to make sure that it's correct and avoid the submission and correction cycle that sometimes happen when invalid data is submitted. Also, conversion between SDMX formats as well. So particularly if the data collector requires that data is submitted perhaps in a particular format, they may define that data must be submitted in perhaps one of the XML formats for SDMX, and then FMR can actually do this conversion between four formats, so can convert between Excel and XML, or CSV and XML, or even JSON as well. And finally, data mapping is the transformation. So transformation of data between maybe the structure in which data is held internally into the data structure definition, which is defined by the collector. So actually, this mapping and transformation or structural transformation of data from one DSD to another could be very helpful for data reporting. And all of this is supported by Fusion Metadata Registry. So last thing to note, and something that we do fairly extensively in the BIS, is use FMR for these so-called metadata-driven solutions. So in that case, instances of FMR hold the master metadata, which drives all the data production, data processing. So as a metadata registry, it is a very key component in potentially creating these metadata-driven solutions where everything is managed and controlled by a central copy and metadata held in an FMR instance. So right, let's talk about some concrete things. So very briefly, let's talk about installing FMR, and we'll get on to doing this in practice. So FMR is a Java web application. And what that means is that it will run on Windows, Linux, and Mac, and other platforms as well. But there are a couple of options to install it. And the first option is you can install it on what's called the Java Web Application Server, and typically this would be something like Apache Tomcat, which is one of these free-to-use Java web application servers. And this is a good choice, perhaps, if you are intending to run FMR in sort of production, and particularly enterprise deployments. So if you want to do, you want more flexibility in the way that the application is set up and managed and handled. But the option we're going to look at today, though, is the simplest. So certainly the simplest to get working, and that's running FMR in the container. And we're going to look at the way of running a container using this free-to-use tool called Docker as such. And this is a fairly sort of simple way, very good for actually starting up FMR very quickly, very useful if you want to run it on your desktop, and is also suitable for light production workloads as well. So let's see this in practice. How does that actually works? So we can run FMR using well, first thing that we need to do to run using Docker is to install a tool called Docker Desktop, which there's a link here when we'll share the presentation after the webinar. So you can click and get that and download it. Again, it's a free to use tool, but fundamentally it's actually used for running these containers actually in a desktop top environment. So the second step is to from the command prompt. So this is an example of Windows. You can do something similar in Linux and in Mac. But the second step is just to run a single command. What the single command is going to do is it's going to download an instance of FMR, and it's going to spin it up as a container. And that's fundamentally it. So let's go and actually try that in practice. So if I go back, so we'll actually do this. So if I run a command prompt, so I've got a command prompt here, and I put that into the command prompt, then what you'll probably see first off when Fusion Metadata Registry starts is you'll see it will go back to the Docker repository, and it will pull down the images. So it may take a couple of minutes or so to pull down the images, but as soon as the images are available, then it will actually start Fusion Metadata Registry. And that'll take probably maybe a minute, and you'll see some sort of logging output as it actually begins to start the Fusion Metadata Registry. And here it comes. So starting up various parts of the application. But then when that's ready, we can access the actual UI of Fusion Metadata Registry very easily by just clicking on this link or just selecting this link here, localhost port 8080. In fact, the metadata registry is still starting, so it's still starting, and there it is. So there's a copy of Fusion Metadata Registry, which we've actually just spun up within a Docker container. So although I did have the images actually downloaded previously, that took probably about two minutes to actually start up a new instance of Fusion Metadata Registry, and immediately we can see the copy as we download it has got some metadata sort of pre-populated in here. So we'll see a few example structures and things. So very quick and simple to start it up. Once you have FMR, once you have the Docker desktop container software actually installed on your machine. So we know sometimes that depending upon your institution's IT policies, you may not be able to install Docker desktop. So if that happens to you, then probably your option is to ask for a exemption from your central IT, or maybe use another machine. But provided you can install Docker desktop, then it's a very simple, literally one step process, one command process in order to start up and run an instance of Fusion Metadata Registry on your machine. So let's very briefly look about maintaining structures. So again, because this is a hands-on, let's return to our registry. So we can go to the Fusion Metadata Registry instance that we literally just started up, and return to this part of the UI which concerns maintaining of structures. So I just logged in there because we need to log in order to actually maintain structures. So we spotted earlier that from the menu here we have this option of creating new structures, editing structures, and deleting structures. So let's see that in practice, and let's start maybe by editing a data structure definition. So this is one of obviously the key artifacts and something that people would be most interested in here. So I've selected this particular DST here, and if I choose edit from the menu, we immediately see we're given this wizard. So in this particular case, it's a data structure definition, the wizard, and we'll see this wizard for every single one of the structures. So maintaining or authoring or editing any one of the structures, you'll see a very similar sort of four step wizard here. And the first part of the wizard is always the same. It's the basic information about the structure, the information which is common to every single structure, and that is the ID in the SDMX terminology, and every structure also has a name, and there's also some various other things that you can attach to it, like a description and sort of validity and things that we won't go into. But you'll see this basic element of the wizard is the same for every single structure. So if we choose the next button down at the bottom right hand corner, we move now to the next element, and of course in the DSD this is about choosing the concepts. So these are about choosing the components that make up our DSD. So we have an option here to choose concepts. So if I were maybe to add another concept here, it gives us the option to search the list of concepts. So what it's done is it's gone back to the entire list of concepts we actually have within our FMR instance, and in this case there's a fair amount, and I can choose a new concept, and I can add that to the DSD. So very easy to create and maintain DSDs by picking the concepts from the list between the list of concepts which you will have previously created or previously loaded into your FMR. And in terms of the component types, obviously within the data structure definition, the concepts take on various types. There can be dimensions, there can be measures, there can be attributes and things. Very easy to choose those by choosing the component type from the drop down. So within the DSD as well, we also think things like dimension positioning is very important. So the ordering of dimensions is extremely important because that's used within the REST API. So the third step of the wizard is choosing the position of our dimensions, and also choosing the representation as well. So you'll probably be familiar with the fact that a dimension or an attribute within a data structure definition can have either can be enumerated, so we can have a code list attached, as we can see here. So our FREC dimension here, we have attached the a CL FREC code list. So from here within the wizard, we can amend that if we want to. We can maybe attach a different code list if we don't like the one that's attached, or we can change the other representation as well. So we can see down from some of these other attributes like the observation pre-break value here. We can see it's defined as a string. And if I were to choose change there, then maybe I can choose another representation for that, and I may be able to say this isn't a string. This is one of the other standard representations that SDMX defines, perhaps in terms of decimal or a number in that case. And finally, for DSD, moving towards the final, I accidentally chose finish there. We try and repeat that. So finally, just to flick back here, the fourth step of the DSD wizards is to do with attribute attachment. And again, you may be familiar in the SDMX information model, attributes, so non-dimensional components, but attribute components, particularly things like pre-breaks and observation confidentiality, and all of these other attributes can be attached at various different levels. Then as step 4 in the wizard helps you do that. I mean, we can define whether to attach the data set, the series, the observation, or the group level, and that's defined in the final section of the wizard there. So that's a basic overview of maintaining structures as well, and there is and as we'll see, the same method is used for basically every single structure. So maybe if we to illustrate a point, if we look at the code list here and choose a code list in random, and again we sort of follow exactly the same workflow. So we choose a code list from our maintenance menu. We choose edit. And again, we see exactly the same four-step wizard format, exactly the same initial step, which defines our basic information for this particular artifact. We can see it's got an ID of CL decimals, you can see it's got version, you can see it's got name, the description, etc. But as we move through, we now see that the second, third, and fourth elements of the wizard are slightly different, because this is a code list and not a data structure definition. For code lists, we can do useful things like importing codes from CSV. So if we want to maintain our codes as a CSV file, or maybe just enter those. So I could do something like ABC. The first code, I can enter it there, or cut and paste. So a very nice feature helping to maintain codes in bulk. Do I want to add the code? Yes, I do. And then finally, there's options for maintaining, editing, and deleting codes. And then finally, code ordering and hierarchies as well. So code ordering is very useful. So you can maintain code orders, and you can also maintain basic hierarchies there. So the fundamentals of maintaining, creating, and maintaining structures are exactly the same for every single structure that you see. Choose a structure if you want to maintain it or edit it. Choose the edit function from the maintenance menu at the top after logging in, and follow the four-step wizard. And if you want to maintain or create a new structure, the wizard's exactly the same as well, except we have to fill in the details from scratch. So if we were to create a new code list, the first thing that we need to do is to find an ID of it, and we might call it new code list, or whatever we happen to choose, but the process is precisely the same. So we'll leave that there for now. I think hopefully we've got the basic idea of a sort of creating and maintaining structures using the UI. The final thing I just wanted to highlight, though, is another useful way of maintaining structures, which is this button down here, which again you'll see for most structures, which is export Excel. And in fact, you can actually use Excel for maintaining structures as well, and again particularly useful perhaps for large code lists, where you have many items, and it's an easier option to maintain in Excel. And you can export the structure in Excel. So if I just choose a code list and choose export Excel, I click on the button. There we go. Out of the way, it's downloaded it. And we'll see we have an Excel file in our downloads. So let's just go ahead and open that up. And here it comes. And there's an Excel representation of our code lists. So we can see all the codes, we can see the locales, we can see descriptions, and we can go ahead and we can modify this code list if we need to. And the really nice thing about this is that once you've modified that code list, then you can actually load the Excel directly back. So if you remember, we had this option here once you've logged into load structures. And in fact, we can load, I choose the file, we can load an Excel directly. So if I go and find that file, that CL decimals code list in Excel, we can load that directly. Basically what that's telling me is nothing was changed, but fundamentally, if you maintain your structures using Excel, then they can be loaded using the load structures option in exactly the same way as if we were loading structures from an XML format or one of the other formats. So let's very briefly turn now to working with data. So we've looked at referential metadata. So we just want to look at these data functions that we saw at the beginning of the webinar. We said that not only is FMR a database and a maintenance tool for structural metadata, but we can also do something useful with that in terms of actually processing XML SDMX data, and there are these three functions it performs in terms of validating data, converting data between these formats, and also potentially of mapping data between structures. So if you remember when we took the tour of the UI, all of the data processing is done under the data menu. And we used this function under convert data called convert data. to actually do all of the data processing functions. And in fact, the data processing always follows effectively a three-step process. So step one is to load your data. As soon as the data is loaded, then the Fusion Metadata Registry will automatically validate it. Once the data has been validated, then we have a choice of either converting the data and outputting it as another format, perhaps as one of the XML or the CSV or the JSON formats, or even Excel. Or if we do have some mapping, some transformations set up, then we can actually sort of map and transform the data at the same time as we convert it. So we follow this three-step process of loading the data, validating it, and then converting and transforming it and outputting the data. So let's return to our registry, and maybe we can see that in action then. So here we are. So we're back at our Fusion Metadata Registry instance. And if you remember, all data processing is done under the data menu and under the convert data option. And when we choose the convert data option, of course, the first thing it tells us to do is load some data. And there are a couple of options for that. We can load data from file. Well, in fact, we could load data from URL. So again, if the data is available on a URL somewhere, maybe it's published by another data publisher, or on a REST service, or maybe just as a file on the URL, then you can load it as a URL. But today we're going to look at the option of loading it directly from a URL. So let's do an example load, and just to show you what I'm going to load, I have actually created an example DSD. So we can filter for structures just by putting a text string into the search box there on all structures. So here's our DSD, which I happen to call banking statistics, and it's a very simple DSD. It's only got 4 dimensions. There's this one called economic indicator, which is enumerated as a code list attached. There's one called frequency with the usual frequency codes, reference area, and there's also a time period as well, and some observation values. So a very simple DSD. And in fact, what I'm going to do is I'm going to load that. I'm going to load that from a file. So I've created some CSV data here, which I'm going to load. So this isn't really in an XML format. It's just simply in the CSV format. In fact, we can actually see the CSV data here. So if you remember, we had these dimensions of economic indicator, frequency, reference area. So here's our CSV data, 1 row per observation. Here's our observations, time period, observation value, just you know, test data for demonstration purposes. So this is the CSV data we're going to load. So I've chosen my CSV file here. When I click load data, the first thing Fusion Metadata Registry does is it validates it. And in fact, it's telling us by these pink boxes that we have some validation errors. And we can click on the error, and it will tell us what the validation error is. And I apologize if that's a little bit small, but what this is telling us is that there's an error here to do with time periods, and it's telling us that it's spotted one observation where the frequency was defined as M, as monthly, but in fact the observation date appeared to be 2021, which is the annual date. And in fact, if we go back to our data and we look down, we can actually see that in here. So we have a frequency of M, indicates the observation should have been a monthly observation, but in fact the time period that was defined for that was the annual time period. So it shows us a validation error for time period. And just as an example, there's another error here under representation, and in fact it's telling us here that we reported a value for reference area which it didn't recognize, so we reported a value in value for reference area. And in fact, we should be able to see that somewhere. Just search for that. There we go. So there's our row. So in fact, there's an error in the reference area coded value here. Should have been PT, was actually TTP, and Fusion Metadata Registry picked that up as an invalid value against the code list that we'd defined. So what we could then do is go away and fix that fix that error. If I go back to my registry, wherever it's gone. So go back to convert that. In fact, I'll choose another CSV file, which I have previously corrected. I'll load that. Then, in fact, now FMR tells us that all the validation checks passed, and the data is actually valid against the data structure definition. So we've been through steps 1 and 2. So we've been through the load process, we've been through the validation process. The final process is convert, and there's a button here called convert data. And this gives us the option to output the data in any one of the formats which are available. In fact, we can choose one of the SDMX formats, and the FMR supports quite a few of the SDMX formats, or the SDMX 2.1 formats, the XML formats, some of the CSV formats as well, JSON, and actually even EDI, if you're still using EDI and you use case. So it's very simple. Choose our format, in this case SDMX 2.1 structure specific. Download that, and that's it. And that's our data. It's downloaded in the browser. And in fact, if I just click on that, that should open it up. In fact, if I just pretty print that. So this is our data, the data that we originally submitted and validated in CSV, and there it is. It's been converted into SDMX 2.1 XML structure specific, if that's the output format that we want. So very easy to validate and convert data using the metadata which is stored in Fusion Metadata Registry. The very final bit I wanted to touch on is this mapping and transformation. Well, it just so happens that within this particular registry, I have a structure map set up for this particular data structure definition. The structure map defines a mapping from the DSD that I set up for the imported data set to another DSD, in this case, which happens to be another one that we use in the BAS called BIS macro. So if you do have a structure map set up, then the mapping option will appear in your download and convert option here to do a mapping, or to convert the structure of the data not only to a different format like XML or JSON or EDI, but also to a different structure. So if I go ahead and choose that, so what I'm now going to do is convert the structure of the data from the import structure, the one that we saw earlier, into this DSD called BIS macro. Then if I do the same process of downloading that, so again we get an XML file just as we did before, but if we look at it this time, it's not particularly easy to see, but actually this is now in a different structure, and in fact, if I hopefully I could zoom in, but I can't. Actually, you may be able to see it there, but then within the structure definition, that actually tells us that this is now in a different DSD, and it follows this data structure definition called BAS macro. So actually doing data conversions, or converting data, or transforming data not only to a different format, to a different structure, is very simple process. It's the 1, 2, 3 step process that we're seeing here. But just to remind that the actual mapping process does actually require the structure maps be defined, which we're not going to go into any detail today. But there can be another webinar on that if anyone's interested. So just to conclude this section with a very brief look at the REST API. And by way of a concrete example, I'm just going to show you perhaps how you can use Fusion Metadata Registry and this REST API with something else, with actually using it with R for data cleaning and data validation. And the process that we're going to use here is we're going to use a code list in Fusion Metadata Registry, and we're going to set up some code in R in order to do some validation on a data frame. Now, in fact, the data frame that we're going to see in R is not an SDMX data structure or anything. It's just a standard R data frame. So, in fact, this illustrates that the metadata that you can use within FMR can be used for purposes outside of a pure SDMX context. So this is the process that we're going to follow. We're going to have a code list in FMR. We're going to set up some code within R in order to import a CSV data set. The validation code in R is going to retrieve a code list from Fusion Metadata Registry directly from its REST API, and then the R code is actually going to validate the data that we've ported into our data frame. So the code looks something like this, but in fact, what I'm going to do is do that live as such. So let's go now to instance of R. So here we are. We have an instance of R. So we're running an instance of R 4.3. And the first thing I need to do is actually load a couple of packages. If I do that correctly, then it might work. So here we go. So we're going to load a couple of libraries, which are libraries actually provided by the Dutch Stats Office. One called there's the standard R SDMX library, and there's also another library called Validate, which is provided by the Dutch Stats Office. So these are standard libraries which can be pulled via the library function. The next thing I'm going to do, just for illustrative purposes, is just read a data set, which I just happen to have in a CSV file into a data frame. So this is standard R. There's no SDMX involved here. And in fact, if we have a look at the data frame, it's very simple. There's literally only two variables in it. One called activity, which is a conceptual sort of coded activity indicator with some values, ED, etc. And there's some observation value as well. So we've got our activity data frame in there. So the next thing I'm going to do is run this function called validator, which is provided by the validate date library. And what this does is it sets up a couple of rules. And in fact, within our validation rules that we set up two validation rules. One says that obs value has to be greater than 0. But interestingly, for our demonstration here, it says that the activity variable, the values of the activity variable, must conform to an SDMX code list. And what it's doing is it's using it's loading the code list from our particular registry, which we defined the API endpoint here, and it's loading a code list from the agency eStat, and it's loading a code list called CSL activity. So it's defining a validation rule that says the activity variable must conform to values that we are going to pull directly from the REST API of our Fusion Metadata Registry from this particular code list. So set up those validation rules. So let's now actually run that validation. So in the validate package provided by the Dutch Stats Office, they have this function called confront. Takes a couple of parameters, the data frame, which we called activity, and the rules, and that's going to go ahead and validate it. And the output of the validation is stored in this object called out. And in fact, they provide within the validate package a nice little way of visualizing what's happened with that. It's called summary, and if you run that, it actually tells us what the result was. And in fact, it tells us that for rule number 1, there were 6 items, which we can see from our data frame, 6 rows in our data frame, and in fact, all of them passed and there were 0 failures. But for validation validation rule 2, there were 6 items, but only 5 of them passed, showing that actually there was 1 failure. So we know that 1 row within our data frame failed validation against this SDMX code list. Final thing we're going to run, actually do that properly, is a final function called violating, which actually shows us what actually failed, and we can see that in fact it was row 6 within our data frame where we defined a value of xxx for the activity value, and it's telling us that it failed on that. And in fact, if we now go back to our registry, in fact, if I go to items, remember that the code lists are under the items here, and I can use our search box activity to actually search quickly for a code list, so we can see the activity code list there. And if I view the code list, and indeed if I search for xxx, indeed xxx does not actually appear within that code list. So the validation that we saw the validation that we saw here occur actually is correct. The validation actually tells us that particular code did not actually exist within the code list. So I'm not going to go any further into the REST API, other than maybe to say that the REST API within Fusion Metadata Registry implements all of the standard SDMX REST API functions as such. So you can retrieve any structure and even maintain structures via the REST API. So we can do something similar here by downloading a code list. So we can construct a URL, and hopefully it helps us to construct the URL to download the code list there. So just to conclude, if I go back to the presentation, just to conclude with a few references as well. So some things that we spoke about today. So we'll show the presentation after webinars. So it's a very helpful page on FMR on the SDMX.io website. It's a link to that. There's also a page on FMR on the BIS open tech site. If you want to use FMR via Docker, there's information about it on the Docker Hub, where the FMR images are stored. And if you do actually want to run FMR as a Java web application, then you can download it here actually on SDMX.io, and there's a link there. Similarly, there's a helpful quick start guide on the wiki, so that this reiterates what we saw today about running FMR as a Docker, but also actually gives all the instructions for actually running as a Java web application if you want to do that. And similarly on the wiki as well, there's a general reference for lots of useful things on FMR. And finally, by no means least, a reference to the Dutch Statute Office, very helpful guide in using doing validation, using R and structural metadata. So the examples that I showed today, using that validate package under R. You can find out more details if you follow that link to their data validation cookbook. So I'm going to pause there, and see we have about 15 minutes left for comments and questions. So maybe I'll just open the floor for comments and questions if there are any. Any questions? So I see one actually question in the chat. Can we have access to recording for this webinar? And the answer is yes. So the webinar is being recorded, and shortly after the close of the webinar, we'll clean it up and we'll put that on the YouTube channel, so it can be downloaded. Simply one, yeah, thank you. Can you share the presentation? So yes, absolutely. So everyone who registered them, then we'll email you the presentation, and again it'll be published on SDMX.io. So thank you all. I see a hand raised from Anna. Let me unmute. Anna, please, would you like to ask your question?
Hello everyone. I wanted to ask about one of the new SDMX 3.0 feature. It's about array values for measures. And so in case if the measure connected to the code list and multiple values allowed it, so array value is allowed, doesn't mean that we would be able to configure constraints that can, let's say, limit some combinations of this code list.
Yeah, it's a great question. So this is about constraints on array values. Yeah, I believe I think we might have to come back to you that with that after consulted sort of someone who's a bit more expert on it than I am. But I've got a feeling that constraints will not you cannot define constraints at the moment to constrain specific array values, if that was what your question was.
Mm-hmm.
But FMR 1111 will allow you to model array values